We're now moving on to page 59 where we're solving more vertical asymptote problems. So on page 59, example 8, the first part of the problem has to do with stating the vertical asymptote, but you also have to describe the behavior of the function to the left and right of each vertical asymptote. So basically I'm asking you the vertical asymptote, does it go to positive infinity or does it go to negative infinity? So we got to figure that out by taking its limit. I don't have enough space to solve these problems, so let's just go ahead and just ignore questions 2 and 3 for now, and let's focus our attention on problem number 1. Now, just by looking at this problem, I know that the vertical asymptote is at x equals to 3. And then from there I need to, so that satisfies the first part of the problem. Then I need to kind of describe what's happening at that vertical asymptote from the left hand side and the right hand side. So if I'm looking at the problem from the left hand side, I write a limit statement as x approaches the vertical asymptote, which is 3, from the right hand side. And I also look at the vertical asymptote when I'm approaching it from the left hand side. And I would just write the original problem here. Sorry, I thought it was a 3, it's supposed to be a 2. So I would just write 2 plus x over x minus 3 and 2 plus x over x minus 3. So I just need to evaluate these limits, and the best way to do these kind of limits is draw a number line with 3 in the middle, and this is the left hand side and this is the right hand side. Let's go ahead and pick numbers on the right hand side of 3 and the left hand side of 3, and I can have 3.1 and 2.9 on the left hand side. Okay, so for the right hand limit, let's go ahead and pick 3.1. So this will be 2 plus 3.1 divided by 3.1 minus 3, and the numerator is positive and the denominator is also positive, so this is positive infinity. For the left hand limit, let me just change colors here. It would be 2 plus, okay, now we're using 2.9 because 2.9 is on the left hand side, all divided by 2.9 minus 3. And if I do that, I get positive infinity on the numerator and I get a positive expression on the numerator and a negative expression on the denominator, and this is negative infinity. Okay, so that's how we do question number 1. I'm going to pause the video, erase this, and then we'll start question number 2 next. Alright, let's move on to question number 2, where I need to find the vertical asymptote. So if you want to find the vertical asymptote, you have to look at your denominator there and set that equal to 0. So if I take the denominator and set that equal to 0, my vertical asymptote is at negative 2. So vertical asymptote at x equals to negative 2. Now I need to describe the behavior of the function to the left and right of each vertical asymptote. So what I need to do next is I need to evaluate the limit as x approaches negative 2, and I need to take a look at that from the right hand side, and I also need to find that limit as I approach negative 2 from the left hand side. And I can just write the original problem here like that. And the best way to solve these one-sided limit problems is by setting up a number line with negative 2 in the middle. I want to look at numbers on the left-hand side and numbers on the right-hand side. So if I go ahead and pick numbers on the right-hand side, I can use negative 1.9, and on the left-hand side, on the right-hand side is negative 1.9, and on the left-hand side, negative 2.01 would be numbers that would work. Okay, let's go ahead and evaluate the right hand limit. So if I plug in negative 1.9 into the problem now I don't really care about the actual numerical values. I just care if the final result is positive or negative. Sorry, not sure why I wrote that. It's just supposed to be a positive sign. The numerator will always be positive because of this power 2, so that's positive. And the denominator is going to be positive, so this final result is positive infinity. And for the left-hand limit, let's go ahead and plug in the numbers here. So now I'm using negative 2.01, so negative 2.01 all squared divided by negative 2.01 plus 2. Now the numerator is positive, and the denominator in this case, if you look at that, that should be negative. So a positive divided by a negative is negative infinity in this case. All right, so once again, I'm just going to pause the video, erase this, and then we'll start question 3 next. All right, moving on to question number 3. If I want to find the vertical asymptote, I take a look at the denominator here, and it's x squared, and I just take the denominator and set that equal to 0. So my vertical asymptote here, you got to be careful here. If you take the square root, the vertical asymptote is just going to be at x equals to 0 there. And now we need to describe the left and right hand side of each vertical asymptote. So just like the previous problems, you want to find the limit as x approaches 0 from the left hand side, and the limit as x approaches 0 from the right hand side. Alright, and we can go ahead and just rewrite the original problem, which was 1 over x squared and 1 over x squared. And in order to evaluate these one-sided limits, you should go ahead and think about a number line with 0 in the middle. And pick a number on the right hand and left hand side, so 0.1 and negative 0.1. So let's go ahead and evaluate the left hand limit first. So this is the left hand side. So if I go ahead and plug that in, I get 1 over negative 0.1 all squared. Actually, we don't really need to pick numbers in this example because the numerator will always be positive, and because of this power 2 here, the denominator will always be positive, so that's going to be positive infinity. And for the right hand limit, the numerator is always positive, and whatever number we put on the denominator, because of that 2, that will always be positive, and that should be positive infinity as well. Alright, so that one wasn't too bad. But I do know that question number 4, this one's require a lot of work. And let's take a look at this question here. Well, we look at our denominator here, and we take our denominator and set that equal to 0. So now I get 1 equals to x squared. But now if you take the square root of both sides, x will be plus or minus 1. So in this problem, you actually have to set up 4 different limit statements, a left hand and a right hand limit for 1, and a left hand and a right one for negative 1. Okay, let's go ahead and set up the limit statements here. So the limit as x approaches 1 from the right, the limit as x approaches 1 from the left, and then there's also a limit as x approaches negative 1 from the right, and finally another limit sign as x approaches negative 1 from the left. And let's go ahead and just write out the original problem for all 4 of these limit statements. Okay, and after that, these are one-sided limits, so I would go ahead and draw a number line here. On the number line, we have the values of negative 1 and positive 1, and let's go ahead and find numbers on the left hand and the right hand side. So how about 1.1 and maybe 0.9 there. For this guy, I will use negative 0.9 and negative 1.1. Alright, so now let's go ahead and evaluate the first limit as we approach 1 from the right hand side. So I will take the 1.1 there. So if I go ahead and evaluate this, well, you know what, the numerator is always going to be positive regardless of what number I plug in there. So I'll be positive over 1 minus 1.1 squared. So the numerator is going to be positive, but the denominator, if you think about that, that should be negative. And that gives you negative infinity. Alright, let's move on to the next limit statement. So in the next limit statement, I'm approaching 1 from the left hand side, so I will use 0.9 to satisfy that condition. If I go ahead and plug the numbers in, once again the numerator will always be positive and the denominator will be 1 minus 0.9 squared. So the numerator is positive and the denominator in this case is also going to be, this one should also be positive as well. So 1 minus 0.9 all squared is still positive, so this is positive infinity. Okay, now let's look at -1 from the right hand side. So if I want to evaluate this limit right here, -1 from the right, I will use negative 0.9. So if I do that, numerator is positive, denominator is 1 minus negative 0.9 all squared. So that's going to be positive, and the bottom one will also be positive as well. So this will be positive infinity for that limit. And finally, we have one last limit statement to look at, and we need to look at the limit as we're approaching -1 from the left hand side. So the last number on my number line is -1.1. So positive on the numerator, 1 minus bracket -1.1 squared. And on the denominator, if I do some mental math here, I'm pretty sure this will be a negative value, so that will be negative infinity there. Okay, great. So that finishes off question number 4. That was quite long, and let's move on to the next page to question number 5. Well, sorry, it's not question number 5. It's actually question number 6. Okay, for question number 6, we have a square root on the bottom. Okay, so I want to find the vertical asymptote. So let's just highlight the whole bottom expression there, and let's figure out how we do that. Okay, so if I take the whole denominator here, actually no way, I don't need the whole denominator. I just need the expression of 2 minus x, and let's go ahead and set that equal to 0. And if I do that, x would equal to 2. So I have a vertical asymptote at x equals to 2. And in order to kind of finish this problem off, I need to take the limit as x approaches 2 from the right hand side, and the limit as x approaches 2 from the left hand side. And my problem here is x over the square root of 2 minus x plus. Now, instead of writing 3, I'm going to go ahead and distribute the limit sign one more time from 2 from the right hand side of this guy right here, which is 3. Okay. Alright, so let's go ahead and evaluate this, and actually I will just write the limit statement on the bottom here as well. Sorry, after you write so many limit problems, you start to go brain dead here. And let's go ahead and now draw the number line with 2 in the middle, and the left hand side and a right hand side. On my right hand side, let's pick 2.1, and we'll use 1.9 on the left hand side. Alright, so let's go ahead and evaluate the right hand side first. So if I'm evaluating the right hand side first, I'll highlight that. I need this number right here, 2.1. So if I plug in 2.1 on the numerator, so that'll be 2.1 over the square root of 2 minus 2.1 plus, now this guy right here, the limit of constant is just a constant, which is 3. Now the problem here is, look at this bottom expression right here. We have a negative on the bottom, but the negative is inside the square root, which makes it undefined. So this whole expression here on the right hand side, this whole thing is undefined because we can't evaluate this expression we can't evaluate this expression right here, so we can just stop right there. I think if you look at the answer key in the workbook, they put a restriction right away, so you don't have to look at the right hand side. Okay, so that's fine. Let's go ahead and do the left hand side. And if I do the left hand side, I need a 1.9. So if I do the left hand side, I'll use 1.9 there. The square root of 2 minus 1.9 plus 3. Okay, so if I evaluate this, if I think about this, the numerator is positive, the denominator is positive, then I have a plus 3 there. Well, positive over positive is infinity, plus 3 is still going to be positive infinity. Okay, so sorry about that. So sloppy work there, but in this question you only need to look at the left-hand limit here because once again, if you think about this question in terms of your pre-calc 11 knowledge, those questions that ask for restrictions, you have to take this 2 minus x, and that has to be greater or equal to 0. And if you do that, then x is less than or equal to 2. So this is really a left-hand limit. So that's why you only need to evaluate that limit to actually get an answer, and the right-hand limit never gave us an answer because of the restriction on that radical. Alright, so that concludes this video, and the next videos will focus on continuity.